Okay, let's look at the questions what we had gone through in the problem set 2. So the first question is to find the coefficient of x cube in the expansion this. So we try to expand this. When we expand this, what we will get is nc 0 4x to the power n, which is 5, then k to the power 0, which is basically 1. Plus we'll have the second term nc1 4x to the power 5 minus 1, which is 4, and k to the power 1, plus nc1 4x to the power 3, k to the power 2, plus other terms. We have to find the coefficient of x cubed. So we are only interested in the term where x to the power 3 is there, which is this term here. It should be 2 here and not 1. So ideally, we should not have expanded it. We could have directly written this term, which contains x to the power 3. So now we calculate this. We write it again here, nc2 4x to the power 3 k square. What is n here? N is equal to 5, which comes from the expression. So we have 5c2, that means 5 factorial divided by 2 factorial divided by 5 minus 2 factorial, which is 3 factorial, into 4x cubed, which is 4 into 4 into 4 x cubed into k square equal to, what is the coefficient? It's 40. So it should be equal to 40x cubed, because 40 is the coefficient of x cube, and on the left side I have written x cube, so it will be equal. So I can remove this. So this numeric part should be equal to 40. So when we solve this, what we are getting is 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. So this 3 factorial can be cancelled out. 2 factorial is 2. So basically this 2 factorial can be cancelled out with 4. It will become 2 into 4 into 4 into 4 equal to 40 into k square. Sorry, I missed the k square. And 40 can be written as 4 into 10. We can cancel this 4 with this 4. And after simplifying, this is 5 into 2, 10. 5 into 2, 10. So this can be cancelled with this 10 here. So on the left side, we have 4 into k square, which is 16k square. On the right side, we have 1. So k equal to 1 by 16. Sorry, k square equal to 1 by 16. And hence k is equal to plus minus 1 by 4. We can test it. So what was our the term where the x cube, what was our x cube term? So our x cube term was this, right? We try to write that again. So our x cube term was nc2 4x to the power cube k square. So since n is 5 here, I can write 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial into, we don't need to write x because x is just a variable. So 4 into 4 into 4, 4 into 4 into 4, and k is 1 by 4 or minus 1 by 4. Since it's square, it doesn't matter. It will be 1 by 4 into 1 by 4. Even if I put 1 by minus 4 into 1 by minus 4, minus 1 into minus 1 will turn out to be plus 1. So when I solve this, I expect this to be equal to 40. So let's see whether it's equal to 40. This 2, 4 will cancel, or this 2, 4. 3 factorial cancels, or 3 factorial. And so what we have, 5 into 4 into, so this 2 I can cancel out this 2. So we have 5 into 4 into 2, which is 5 into 4, 20 into 2, 40, which is same as what was given. So this is the answer. Let's go to the next question. It's similar question which says coefficient of x square term in the expansion of 2x plus 1 to the power n is 60. There is coefficient of x square. So here we will not try to expand everything. We will just, we know the generic term of a binomial theorem is NCR a to the power n minus r b to the power r. So in what is given, our a is 2x, and I want the power of x to be square. I want power of x to be square. That means the power of a to be square. So how will I get this n minus r to be square? So n minus r square means it has to be equal to 2. We have to find n. Right? So now if you see, we have two variables. We don't know what n is. We don't know what r is. So I cannot solve this. Right? It's not solvable because there is only one equation. I have two variables. So I cannot solve it. So what we can do is we can rewrite 2x plus 1 to the power n can be written as 1 plus 2x to the power n. Now if we expand this, our first term will be 1 plus n into two x plus n into n minus 1 by 2 into x square plus n into n minus 1 into n minus 2 by 3 into 2 into 2x cube plus other terms where the power to the x will be 4 or more. So we are not interested in 4 or more. We are not even interested in x to the power 3. What we are interested in, x square. So what is the, let's rewrite it below. So we have n into n minus 1 into n minus, sorry, no, n minus 2. Yeah, so we had n into n minus 1 by 2 into 2x square. And coefficient is given to be 60. So basically this is 60. I put x square. So now we have n into n minus 1 by 2. Okay, I remove this, otherwise it will look like it's a denominator. It's not a denominator. Okay, and I just write it here so it's more clear. 60. So we have n into n minus 1 by 2 into 2x square. So into 4 equal to 60. Okay, this cancels out. So right side will become 2 will go down, it will become 30. N into n minus 1 equal to 30 means n, this is a quadratic equation. So basically the n will have two solutions. One we can easily see. We know that 6 into 5 is equal to 30. That means n equal to 6. Right? Right? There is one more solution if we try. We can also have When we put n is equal to -5, we are getting -5 into -5 minus 1, which is -6 equal to 30. So n can be 6 or n can be -5. Since in the syllabus that we have, n can only be positive. Actually, n is applicable for negative powers as well, and even in any real powers, fraction powers and all. But in our syllabus, n is only applicable for positive. So the correct value will be n equal to 6. Let's try to check whether what we have got is correct or not. So what we have got is n is equal to 6. Let's try to put n is equal to 6 in our original expressions. Our original expression was 2x plus 1 to the power n. 2x plus 1 to the power n. N means this is 6. So now I will not reverse. I will not write 1 plus 2x. I will just try to expand as it is. So we have, and I just want x to the power 2. I'm interested in this. So it will be n CR 2x to the power n minus r 1 to the power r. So now we have n minus r should be 2 because I'm interested in x to the power 2. I have got n, which is 6, minus r equal to 2. So r is 4. So if I put r as 4, we'll get 6 C4 2x to the power n minus r, which is 2. 1 to the power r, any number will be 1. So now it's 6 into 5 into 4 factorial divided by 4 factorial into 6 minus 4, which is 2 factorial, into 2 into 2, the bracket 1 will be 4. So this 4 factorial and 4 factorial can be cancelled out. 2 factorial is basically 2, so this one will become 2. So we have 6 into 5 into 2, which is equal to 60, which is same as what the question asked, 60. Now let's look into the third question. Okay, so it says prove this is equal to 4 to the power n. If we take a look at this and observe, this is similar to binomial theorem. And binomial theorem, a plus b to the power n can be simplified as a to the power n 1 plus b by a to the power n, which can be, if we replace b by a equal to x, it can be simplified and we take out a to the power n, or we don't leave it, we can just write 1 to the x to the power n. Okay. So if we look at this, or okay, we try to expand 1 to 1 plus x to the power n, then we will see one of the term will be similar to what is given in the question. 1 plus x to the power n is 1 plus nc 1 x plus nc 2 x square plus nc 3 x cube plus nc 4 x to the power 4 plus all the way up to ncn x to the power n. Now we look at what is given. What we have is summation of ncr 3 to the power n. Like ncr, the first term will be nc0 3 to the power 0 plus nc1 3 to the power 1 plus nc2 3 to the power 2. This can be written as 1, nc0 is 1 and 3 to the power 0 is 1. So 1 into 1 is 1. So it's basically 1 plus this term plus this term. And this is similar to this here, right? We have 1 in both. We have NC1 into x, NC1 into 3, NC2 into x square, NC2 into 3 square. So basically, this thing can be written as 1 plus 3 to the power n. We can expand the binomial theorem. We can also contract it. If we have the expanded form, we can always write the short notation. So 1 plus x to the power n can be expanded as this. But if we have this expression, we can also write it as 1 plus x to the power n. So basically, this thing is a binomial expansion, which can be written as 1 plus 3 to the power n, which is equal to 4 to the power n, which is same as the right hand side.